Okay, so today we're going to have a look at chapter 35, Galaxy Stars in the Solar System. It's actually divided into three, so today we're going to focus on stars. So stars are luminous objects, and a luminous object is an object which gives out its own light. Stars are made up of gas, and stars give out their own light by nuclear reactions, and we've looked at a nucleus already in chemistry. So within that nucleus, we have reactions that occur, and these are called nuclear reactions. What does this word luminous mean? And it means it gives out its own light. And we have loads of different examples of luminous objects. So some of them here are a high visibility vest, a bulb, bike reflectors, the sun itself. Okay, so all of these are examples of luminous objects. They give out their own light. Okay, stars then is the one that we're going to look at. The sun actually is a star. So what happens in these nuclear reactions? So we've two hydrogen atoms fusing, and to fuse just means that they join together, okay? And again, we've looked at hydrogen, okay? It is the first element in our periodic table. And when they join together, they form helium, and helium is actually the second element in our periodic table. Remember, my symbol for hydrogen is H, and my symbol for helium is He. And when they do this nuclear reaction, they end up releasing heat and light, and that causes the stars to shine. So when we look up at the star, it is these nuclear reactions that allow us to see it. There are billions upon billions upon billions of stars in the sky. If you take it as an example of going to the beach and the grains of sand, all of those grains of sand at a beach would be an example of the amount of stars that we have in our sky. Estimated at 100 octillion. Okay, so octillion is a huge, huge, huge number. Okay. When we look at a star then, it has its own lifetime. And every star is going to be different, and it's going to be in a different stage in its life cycle. Much like with us as humans, we have different phases. We have babies, we have toddlers, then we have children, you have adolescents, and finally you have an adult. Same here with the star, except they have 4 different life cycles or phases. The first one is formation. So formation means how it's made. The second is its stable period. Phase 3 is called red giant, and phase 4 is called white dwarf. So you need to know each of those 4 phases. We're just going to look at each of these now in a little bit more detail. So phase 1 is formation. Okay, and basically what happens is that a lot of gas accumulates together, and when they do that, they form large gas clouds, and these are called nebulae, Nebulae. Okay, and gravity is what causes these gases to come together, and when they come together, the gravity holds them together, and we end up then with the star. In its stable period then, the star is going to spend most of its life in this phase, and it can glow for billions of years, which is the sun, okay? And the sun is in our stable period. And in the stable period, there's a balance, and there's a balance between the gravity trying to make the star smaller or shrink it, and the heat energy trying to expand, and those equal each other out. So it's stable, maintaining its same size. And this is our sun, and it is our main sequence star. Okay, it's the sun and the star around which all our planets rotate and orbit, and we'll be coming to that later on in the chapter. The third phase then of a star is red giant. And in a red giant, my gravity can no longer shrink it enough, so it releases more and more heat. And as it does that, the star expands and gets bigger until it eventually becomes a huge structure. They believe that this will eventually obviously happen. The sun, remember the sun is a star, so it'll get so big that it will destroy Earth. However, they do think this will be 5 billion years from now. Okay, so if you imagine it like a balloon, so you blow up a balloon, the balloon gets bigger and bigger and bigger and bigger and bigger and bigger and bigger until eventually it pops. And that's what phase 4 is, white dwarf. And this is where it condenses and it collapses in on itself. So the best example there is the balloon. Okay, so it gets bigger and bigger and bigger until it can no longer get any bigger anymore, and then it collapses in on itself. And it forms a very, very, very tiny dense star, and it will emit less and less light until eventually none. And once that happens, the star is gone. Okay. We have then a few phenomena. So one of the things is called a supernova. And this is very rarely seen, but it's when a star dies. And some stars can produce a dazzling amount of light. And this is called a supernova. The idea then of stargazing, this isn't a brand new phenomenon. Loads of different astronomers, Greeks, Romans, they all looked into the sky. And when the stars emit light, that light actually takes time to travel through space to Earth. So in essence, what you're actually looking at is you are seeing a star millions upon millions of years ago. Okay, so looking into the night sky is actually like looking back in time, and possibly even millions of years, depending on how far away that star actually is from Earth. Okay, that is the end of stars.